Hello. So today I'm going to be talking about the chain rule with several independent variables. So the chain rule is if you take the concept of it, you're defining a certain function inside, let's for example, a sine or a cosine with a certain value, right? So that's kind of the same principle with the chain rule. So let's say we have this function, right? Z is equal to 9x squared plus y, right? And the x and the y is actually defined in different terms, so it's a parametric function. It's parameterized. It's been parameterized with two variables, with the s to the third plus t to the second, and then y equals s t to the negative one. So how can we do this? Well, there's a little formula that's derived from the chain rule with single variable calculus. So, like for example, if you're trying to take the partial derivative of z to respect to s, right? All you have to do is take the partial of z and the partial of x times the partial of x to the partial of s plus the partial of z, the partial of y times the partial of y over the partial of z. Oops, sorry, I meant s. So if you notice, these two partials go together, and then this is always what you're in respect to right here. So if we follow this, we can say, okay, so this can be, so let's do the partial. So the partial of z with respect to x, that's going to be 18 x y. That's being multiplied by the partial of x to respect to s. So this t will go away, so it will be 3s squared plus partial of z to respect to y, that just be 9x squared multiplied by the part, this is the function, so it will just be t to the negative 1. So now we can simplify this a little better. So if we say, so the 18, so that would be 54, 54xy s squared plus 9x squared t to the negative 1. Okay, so we want everything in respect to x, to s and t's. So we have to replace what x and y is. So we can do this because this function is already defined for us. So we have 54 times s to the third plus t to the second s squared plus 9, the x squared, the x is going to be s to the 3 plus t to the second all squared all over t. The negative 1 is going to bring that down. Okay, so yep. So I'm just checking everything is correct. 54. Oh, forgot something. So this 54. So the 54 is correct. I'm just gonna put something here. Because I forgot to substitute in my y. So my y, right? My y is s to the t, right? And then this is 54. Okay, so now we can, we can make this look a little nicer. So if we have 54 s to the third times s to the third plus t to the second plus 9s to the third plus t to the second all over t. So that's our function. You could expand this, but overall this is fine. So that's how your function is going to look like. Okay, so that's in respect to s, but what about in respect to t? Well, we gotta follow the same format. So we follow the same format. Instead of s, it would be the t's. So let's do that. Okay, so z to respect to x, that's gonna be 18xy times x to the second, so 2t, because now we're doing respect to t, so we put s as a constant. Then we have plus, and then we have 9x squared, and then this is respect to t, so this would become negative s t to the negative 2. Yep. Yeah. So now let's clean it up again. So we have 36xy t minus 9x squared s. Let's put this t right here, squared. Okay, so now we can make substitutions. So this 36 will be, with the x, will be s to the 3 plus t second, and then this would be s to the t minus 9. We just have to substitute one thing, so we can do the x squared, so s to the third plus t to the second squared. We can put the s right here, and then the t squared. And now if we want to make it a little neater, we can say, okay, so we gotta have a t squared in both sides, so we can say 36 ts s to the third plus t to the second minus 9s s to the third plus t to the second squared all over t squared. Then that became our partial of z with respect to t. And then this one became the partial of z with respect to s. Yeah. So overall, that's a chain rule. It can be a process, especially if your teacher wants you to simplify it all out. It can be very tedious. But overall, this is the correct method to do it. Okay. Thank you.